Hello all, welcome to the video lecture. This is Ramesh Lama. In this video lecture, we will be discussing about Hive and Spark. While talking about the Hive, let's recap basic concepts of big data. Well, we know the term big data is used for collection of large data set that include huge volume data with high velocity of generation and the variety of data that is increasing day by day. We know using traditional data management systems, it is difficult to process this kind of big data. Therefore, the Apache Software Foundation introduced a framework which is known as Hadoop to solve the big data management and processing challenges. And the two components are the most important components of the Hadoop are the Hadoop MapReduce and SDFS. This MapReduce is a parallel programming model for processing large amounts of structured, semi-structured, and unstructured data on the large cluster of the commodity hardware. Similarly, SDFS, which is Hadoop distributed file system, is a part of Hadoop framework, which is used to store the data sets, and it provides a fault-tolerant file system to run on the commodity hardware. And well, we can execute the MapReduce operations in multiple ways. First one is using Java MapReduce program for structured, semi-structured, and unstructured data. And the next is the using the scripting approach for MapReduce to process the structured and semi-structured data using the big language. This is big that we briefly discussed in our last class. And third one is the Hive query language, which is known as HiveQL or HQL for MapReduce to process the structured data using the Hive. So we will see basics of Hive, and this let's have a brief overview of Hive. It is data warehouse infrastructure tool which is used to process structured data in the Hadoop ecosystem, and it resides on the top of Hadoop to summarize the big data, and it makes querying and analyzing of the data easy. And it was developed by Facebook initially, and later it was given to Apache Software, or Apache Software Foundation took it up and developed it further as an open source under the name of Apache Hive. And the few features, some of the important features of the Hive are it stores schema, which is a logical configuration of all logical configuration or part of relational database. It is like this schema gives us the logical configuration of the of all or the part of relational database. Basically, this Hive stores the schema in the database and processes data in the SDFS, and it is designed for the OLAP, which is online analytical processing. And the main important point is it provides the SQL type language for querying called HiveQL or SQL, and using this we can perform some kind of analysis, and we can get the data, and it is fast, scalable, and extensible. So these are the basics feature of Hive. And as we know, like industries are using Hadoop extensively to analyze their data sets, and the main reason behind using this Hadoop framework is like it's based on a simple programming model, MapReduce, and it enables computing solution that is scalable, flexible, and like it's fault tolerant, and more importantly it is cost effective. And lots of industries are using Hadoop. However, Hadoop is not free from its drawbacks. These drawbacks includes low processing speed, lack of data pipelining, like latency problem, and so on. So Spark was introduced by the Apache Software Foundation, and it was basically introduced for speeding up the Hadoop computational computing software process. And Apache Spark is also known as lightning fast cluster computing technology, and it is designed for the fast computation, as I have said before. And it is based on Hadoop MapReduce, and it extends the MapReduce model to effectively use it for more types of computation, which includes interactive queries and stream processing. Even it provides some kind of machine learning capabilities and some graph processing capabilities. And the main feature of Spark is its in-memory cluster computing. That is like it increases the processing speed of an applications, like as it's performed on the memory, like the computations are performed on the data using the in memory, like it saves the time for accessing the disk. So some of the important features of Spark are like the most important feature is speed, like it helps to run the applications in Hadoop cluster, and the speed is up to 100 times faster in memory, and even if it runs on the disk, it is also 10 times faster than Hadoop. And this is possible by reducing the number of read and write operations on the disk. And it main thing is it stores the intermediate processing data in the memory. So that's why the speed of this Spark processing time is very fast, like it's up to 100 times faster than the Hadoop. And another feature is it supports multiple languages, like it provides built-in APIs in Java, Scala, or Python, and therefore applications can be written in different languages. And another feature of the Spark is advanced analytics. It not only supports map and reduce, like that map and reduce is the processing scheme that we get in the Hadoop. It not only supports MapReduce, it also supports the SQL queries, streaming data, machine learning, ML, and graph algorithms. So because of this, we can use it for the processing of the big data more efficiently. So let's see some of the components. Like it consists of the Spark SQL, Spark streaming, MLIB, machine learning libraries, and GraphX, graph, and the Apache Spark core. And let's start with the Apache Spark core. Like it is the base engine for large-scale parallel and distributed data processing, and it is mainly responsible for memory management and fault recovery, and it's also responsible for scheduling, distributing and monitoring the jobs on the cluster. And it's also responsible for interacting with the storage systems. And another tool is the Spark SQL. It is a Spark component that supports querying data either using SQL or via the Hive query language, SQL. And it originated as Apache Hive port to run on the top of Spark, like in the place of MapReduce, and it is now integrated with the Spark stack. So In addition to providing support for various data sources, it makes it possible to web SQL queries with the code transformations, which results in the very powerful tool. So another important component is the Spark streaming. It supports real-time processing of streaming data, such as production of web servers, log files, like Apache Plume and SDFS S3, and social media like Twitter, and various messaging queries like Kafka. And under this, the Spark streaming, under the Hadoop, the Spark streaming receives the data streams and divides the data into the batches, and next they get processed by the Spark engine and generate the final stream of the results in batches. And another important component of Spark is the machine learning library. This is MLIV is the machine learning library which provides various algorithms designed to scale out the cluster for classifications like regression, clustering, and collaborative filtering, which is the core component of data analytics. And some of these algorithms also work with streaming data, such as linear regression using ordinary least square or k-means clustering. And we can use lots of machine learning algorithms using MLIV. Like this MLIV can be used to run machine learning task. And GraphX is another component of the Spark, which is the library for manipulating graphs and performing the graph parallel operations. And apart from built-in operations from the graph manipulation, it provides a library of common graph algorithms such as PageRank. I think this PageRank is a very popular algorithm for used by the Google. And use case, let's see some of the use cases. Like lots of companies are using this Spark for its big data analytics, and some of the companies like eBay, Alibaba, and Netflix, they are currently using this Apache Spark. And this eBay deploys Apache Spark to provide discounts and offers to its customers based on their earlier purchases, and using not only enhances the like using this, it not only enhances the customer experience, but also it helps the company to provide a smooth and efficient user interface for the customers. And another company is like Alibaba, which runs the largest Spark jobs in the world. And some of these jobs analyze big data, while rest of the performs the extraction of the image data. So these components are displayed on the large graph Spark, and it is used for deriving the results as well. And another use case is in media and entertainment. Like some of the video streaming websites, they also use this Apache Spark, which along with MongoDB, and it shows the relevant ads to their users, and basically based on their previous activity on that website. And one of the example is Netflix, which it uses this Spark to recommend the shows to its user based on their previous shows they have watched. So based on the previous activity, this media and entertainment industry uses this Spark to show the recommendation to their customer. And these are some of the basic examples of the use cases. And we can use Hadoop and Spark together, because there are some scenarios where Hadoop and Spark can go hand in hand. Like Spark can run on the Hadoop standalone and Mesos YAM or in the cloud. So as we know, Spark's machine learning library components, they provide capabilities that are not easily achieved by the Hadoop MapReduce. So by using these components, machine learning algorithms can be executed faster inside the memory, as we know that this Spark processing is very fast compared to the Hadoop. So we can use these components, and Spark doesn't have its distributed file system, so combining this Spark with the Hadoop, various Hadoop capabilities can be used. And for example, resources are managed using via yarn and so on. So in this way, this stops these two platform can go together for the better and for efficient analysis or for better production of the for the for the like we can use efficiently, we can process the data, or we can perform big data analytics very efficiently using these two platform together. So it's all about the big data analytics tools. Like there are lots of big data analytics tools now in use in the market, like and in this section, like I didn't cover in more detail, I just tried to give the overview of the big data analytics tools. And so like if you are interested, you can go in more detail, and you can have you can do some projects on. If you are if you want to go in more detail, like you can use these tools. And like in my class, it was just the overview, like it was not in depth, it was just a brief overview. So from our next class, we will be discussing about we'll be discussing about the algorithms that is used for the big data analytics. So it's all for now, and it's all for now for the big analytics. Like these are the tools. So from our next class, we'll be discussing about the big data analytics algorithms. And